Hello everyone, it's an honor to be here at such a special time. Firstly, I'd like to thank the committee for providing us with such an online communication opportunity. Today, my presentation will be related to the estimation of capacity utilization, and we use our newly proposed method in doing an empirical study on Chinese manufacturing industries. My presentation will contain four main parts. First of all, let's have a look at the development path and the problems of Chinese manufacturing industries. As we all know, since the reform and the open door policy, China has experienced significant progress in terms of social and economic development. For instance, China's GDP increased by approximately 4 times between 2003 and 2012. The value added by the industrial sector increased from less than 6,000 billion yuan to nearly 20,000 billion yuan during this time period. Besides, in the international market, China's industrial products occupy an increasingly large share, which can be reflected in the field of fiber, toys, apparel, garments, air conditioner, and so on. However, two severe problems occurred in Chinese manufacturing industries. The first problem is energy consumption and environmental pollution. China has become the world's largest consumer of energy since 2010, and it also became the world's largest contributor of carbon dioxide emission since 2007. China produced more than 2 billion tons of industrial solid waste in 2009, which was 5.4 times the amount generated in 1981. To overcome this problem, Chinese government has taken actions to do environmental protection, emission reduction, and formulated many new green regulations. The second problem is overcapacity. In our opinion, Chinese manufacturing industries experienced four main stages. The first stage was a production rapidly expansion period. Since the global subprime crisis in 2008, the demand sharply declined. Then Chinese State Council approved a massive stimulus package to upgrade the infrastructure. After that, due to the insufficient external demand and old-fashioned production facilities, the overcapacity problem exposed and lasted until now. Therefore, we can see there is growing pressure on China's manufacturing industries to minimize their negative impacts on the environment and eliminate excess capacity at the same time. So a reasonable measure of capacity utilization, considering environmental factor, is of urgent demand, but the existing CU measuring methods ignore the existence of undesirable outputs. The emergence of global subprime crisis in 2008 and the intensified overcapacity problem made the period 2007 to 2010 great researching value. So we propose a new measurement of capacity utilization and try to measure its evolution. Firstly, we partition inputs into variable inputs and fixed inputs. Here we use energy consumption and labor as variable inputs and use assets as the fixed inputs. We use gross industrial output value as the desirable output and use carbon dioxide emission as the undesirable output. To measure the capacity utilization, we first calculate the restricted directional distance function, D0, to reflect the inefficiency between the actual output and its benchmark efficient output. Then we further calculate the unrestricted DDF D0 hat to show the inefficiency between the actual output and its benchmark capacity output. Therefore, we can measure the capacity utilization as the difference between D0 hat and D0. Here we can see that the actual input-output point EY can move on to the efficient frontier through eliminating the inefficiency D0, and it can further move to a more higher level through eliminating the inefficiency D0 hat. This figure also illustrates that CU can be seen as the difference between D0 hat and D0. As a byproduct, our newly proposed model can also recognize the optimal amount of variable inputs and the full capacity outputs. Besides, we can classify two kinds of overcapacity according to CU indicator and the optimal amount of variable inputs. When the CU indicator is larger than 0 and no optimal amount of variable inputs less than the actual variable inputs, we consider that these kinds of DMUs have absolute overcapacity, which reveals that surplus purely consists in fixed inputs. If there is a situation where the optimal variable input is less than the actual input and the CU indicator is larger than 0, we can say that this DMU has overcapacity in fixed inputs and underutilized variable inputs. Because our model is constructed on the base of DEA models, so the resultant CU indicator is a relative measure related to other DMU's performance in the same year, and the CU values in different time periods do not have comparability because of the different production frontiers. To overcome this problem, we further incorporate the Lundberg indicator and decompose CU change indicator as Lundberg indicator minus technical change indicator minus inefficiency change indicator. For the sake of verifying the availability of our model, we apply it in an actual case study. Our data are collected from China statistical yearbooks, and we choose 32-digit level manufacturing industries as our research objects. Our investigation period lasts from 2007 to 2010. From the figure in the right-hand side, we can see that all means of 5 indicators increased during the investigated period. After calculating the CU indicator, we draw a picture to see the changing trend of the average CU. It is easy to see that this indicator declined gradually during this period. Since CU is a cost type indicator, this trend indicates that capacity utilization in Chinese manufacturing industries improved during this period. We also classify these DMUs into light industries and heavy industries, and further obtained the CU of these two groups. The average CU results in light industries is larger than that in heavy industries, so there is a more serious overcapacity problem in the light industries. Based on the calculated results, we also conducted the classification on two kinds of overcapacity. Here, we give two examples. For DMU4, its CU scores are larger than 0 during these 4 years, and no optimal variable inputs less than actual variable inputs, so DMU4 has the absolute overcapacity. For DMU21, we can see that its CU scores are larger than 0, and the optimal amount of energy consumption are less than the actual amount, so it has overcapacity in fixed inputs and underutilized variable inputs. Because the incorporation of undesirable outputs in our model, it is necessary to conduct a comparative study between our model and the traditional model. Here we use the kernel density graph to show their differences, and the results illustrate the necessity of the incorporation of undesirable outputs. What's more, we also use the double bootstrap regression analysis to study the impact of environmental variables on our results. We use total working capital as the proxy of economic cycle variable, and value-added tax payable as the proxy of policy variable. The regression results show that CU and the unrestricted DDF both show negative correlation with total working capital and the positive correlation with the value-added tax payable. Therefore, low-level interests and tax will be beneficial for the improvement of capacity utilization and efficiency in Chinese manufacturing industries. Besides, we also calculated the CU change of each DMU. Here we use DMU2 as an example to demonstrate the results. We can see it experienced 2 times of large fluctuations, decreased from larger than 0 to less than 0, and then increased to larger than 0 again. From an average point of view, it is easy to see that average CU change indicator is consistently below 0, which shows that the capacity utilization gradually improved. Besides, the driving force was technical change. In summary, we obtained several findings and according to the results and our analysis, and we also put forward several corresponding policy suggestions. We find that CU of the Chinese manufacturing sector slightly improved. Average CU value of light manufacturing industries is higher than that of the heavy industry manufacturing industries. 2 kinds of overcapacity are recognized during our investigation: a positive correlation between the CU indicator and the value-added tax payable, and a negative correlation between the CU indicator and the total working capital are tested. The driving force of the CU change was technical progress. Based on these findings, our policy suggestions are put forward. Chinese manufacturing industries should improve the existing production technology. Policymakers should adopt different policies to accelerate the technical progress. Chinese government should formulate more industry-specific measures and adopt policies to cut down the massive investments in industries with overcapacity problems. Government authorities should develop several preferential policies, for example, the value-added tax deduction policy for specific industries. That's all about our work. Thank you for your listening, and we hope the epidemic will disappear as soon as possible so that we can get together and communicate our academic progress in person. Thank you.